Greetings, math friends. I would like to talk about the Riemann Stieltjes integral. It's an integral that became important to me as I looked at a particular problem that I was investigating how to handle with what calculus theory would allow me to handle a particular problem. And I'm not wanting to talk about that problem today, but I do want to talk about this integral, which many of you may not have come across if you've had some early calculus or no calculus experience and haven't gotten too deep. This is something that you may have seen if you've been in a real analysis course. And this is going to become kind of an active book review as well. I have taken more than one real analysis course, and I have taught a real analysis course. Some of the textbooks that I'm experienced with are Introductory Analysis, The Theory of Calculus by Fridy. This was the book that I learned from in the transition period between undergraduate to graduate studies. I also studied out of Introduction to Analysis, 5th edition, by Galgan. I also use this as a supplement to the course that I taught. The textbook for the course that I taught was Intermediate Mathematical Analysis by Lebert. This, from the title, doesn't sound like it should be an introductory course since it says intermediate, but it really turns out to be a good book for an introduction course. It goes just a step beyond because it does have some other pieces with complex analysis in there if you want to go a little further. And then one that I've come across and I haven't taught out of it, and I didn't take a class using it, is Elementary Real Analysis by Anderson and Hall. It's got a nice dust jacket on here in pretty decent condition. This one is from 72, so hardback with dust jacket in good condition. As we look at these three texts, looking in the index of each of these, I did not find a reference to the Riemann Stieltjes integral. However, going back to this textbook, which I had studied from in the past, which can be used as a graduate level textbook, I did find the Riemann Stieltjes integral. It starts out near the beginning of the section with a definition. And then we get a theorem that really unlocks that integral for us for well-behaved integrals. Before we get that, just a note, this does have a pretty nice section on axioms for real numbers. On page 11, though, there's a critical typo. There's an inequality that's backwards with the epsilon argument, which is just terrible to have that so close to the beginning of the text. That's one of the biggest drawbacks that I have with this text. This is the 2nd edition. I haven't seen where they've come out with a 3rd edition. This is from 2000. So it's within the last 25 years and not had an updated edition. But still a good text. As we look at Fridy's definition, we see the Riemann Stieltjes integrable function, f, is going to be integrated with respect to a second function, g, and they both have to be defined on the same interval. So The next thing that is in the definition is this number j. The number j, once we get to the end of the definition, and actually it's just outside the definition in the textbook. This comes from page 169 in the textbook. This j is what is really the Riemann Stieltjes integral. So we build this up kind of in pieces through the definition. We have to have that j is a number such that for epsilon greater than 0, we have that j minus partition with the functions and a measurement here. The absolute difference there has to be less than epsilon. And that needs to work regardless of your mu sub k for your x sub k terms. So this isn't mind-blowing really for people that have a background in analysis. If you don't have a background in analysis, this might be pretty foreign to your ideas and thinking. So let's step into the theorem, which really unlocks this for the majority of people. If you have even an introductory calculus background, the theorem unlocks this idea for you. We're going to take these pieces from the definition and build the pieces that make the theorem. One of the things that we have to know is that f is traditionally integral with the Riemann integral. The next thing we have to know is that if we take the derivative of g, the second function that we've identified, that one has to be continuous on the integral. Once we have that, we can take these pieces. J is, by definition, going to be the integral on this interval, a to b, of the function f with respect to the derivative g. And this epsilon delta argument would be what we use to argue some of the truth about this, some proof writing involving this. But further, the theorem is going to tell us how the common calculus user can utilize this. The theorem now equates this, which is the Riemann Stieltjes integral, with the Riemann integral on the same interval. We have the original function times the derivative of the second function, and that is the theorem. And we just find this page or so removed from the definition that Fridy gives us in his textbook. And now with this beautiful theorem, we can start to do a new type of integration using the skill set that we developed in our early calculus classes. All right, let's do a Riemann Stieltjes integration. We're going to have the integration from 0 to 2 of x cubed with respect to x squared. So the first thing that we're going to do is we are going to take the derivative of the second function, which was our g function. So we're looking at g of x being x squared, so we're looking for g prime of x. So this is just taking the normal derivative, so we have 2x. This 2x is going to replace the d of 2x here. All right, so now that we've done that derivative, we've placed it in here. And we need to find an antiderivative to continue the integration. This too can pass through the integrand, and that's going to help us there. The x times the x cubed is going to give us the quartic right here, and then we have that this is we're going to end up with 2 times 1/5 times x to the 5th, evaluated from 0 to 2. We just substitute in now, and we find those solutions. So evaluating this for 2, we have 32/5. Putting 0 into this gives us 0. So then we have 2 times this. So we have 64/5 as our solution. Hopefully this has been an interesting look at a different way of doing calculus than you may have experienced in the past. Hopefully this gives you something to explore with friends in your part of the world. Cheerful calculations.